All right, guys, example 3, we're going to introduce something a little bit different. It's a different way of writing the formula, and there's a reason we're going to do that. And the reason is this right here. The rate that we're given is not a half or double or triple or quadruple. It's a percentage, okay? Anytime you're dealing with growth or decay as a percentage, you're gonna do it a little differently. You're gonna use a slightly different formula, and we'll talk about the reason why. But I want you to think about this. We're increasing at a rate of 4%. So if we originally started the original amount we're starting with 100%, right? And we're going to 104%, if you want to think about it like that. But what I want you to remember is that 100%, if we were to convert that, would be 1. Okay? So what they do, or what they've done, is they've kind of taken that formula that you're used to, so the exponential growth formula, and they simplify it down to A times 1 plus R to the T power. Okay? And this 1 right here comes from the fact that you started with 100%. And then you increase by whatever your rate is, you'll see where we're going to end up with the 104%. So, again, A is your initial amount, the stuff you started with. R is your rate, so growth or decay, still a rate. And then T is your, remember, interval of time. Interval of time. Okay, and then of course Y is the final amount, or the total, right? The total that you end up with. All right, so we're talking about the population of a small town increasing at a rate of 4% per year. All right, cool. If there are currently about 6,000 residents, about how many will there be in 5 years at this growth rate? So assuming no changes there. So we started with 6,000 residents. All right, so A is 6,000. We'll leave out the parenthesis, the comma for the math here. And then 1 plus, now what's our rate of change? It says 4%. But remember, we're not going to plug in the percentages. We want to get them to whole numbers or to decimals. So in this case, our rate, 4%, 4% is 0.04. Okay? So 0.04. Now, we'll talk about what I can do with that in a second and how that relates back to the 104%. And then T is the number of years, so it's per year, and we want to know how many years that's going to be happening for, and they gave it to us here. It's 5. Okay? And then that's going to equal how many people there will be at the end of that 5-year period. So let's clean this up a little bit. We've got 6,000 times 1.04 to the 5th. Now, notice the 1.04 here relates back to the fact that we were going from 100% to 104%, a 4% increase. So you technically could have started with that and replaced this whole 1 plus R thing, but the formulas that you're going to be given, that's your generic growth formula setup, okay? So there we're going to do 1.04 to the 5th power, and you can do that anytime I give you something like this. You'll have access to a calculator for. I don't expect you to be able to do that kind of stuff without. And we're going to leave it, I'm going to leave it out to about 5 decimal places, just like they did in the notes, so that I can keep everything consistent. Okay. And then to clean it up, you'd multiply by 6,000. In your calculator, if it goes out further than this, I wouldn't even bother rounding. I would just hit the multiplication button and do times 6,000 and then round your final answer. So what we're going to do is we're going to round to approximately 7,300. And again, what does that mean? After 5 years, the population will be approximately 7,300 people. Okay, moving on.